Great. Thanks, Srikanth. So I'm going to talk about what customers want from Wi-Fi. So I've been traveling over the last year. I met more than 100 Wi-Fi companies all around the world in more than 15 countries. This is the map of all the places I traveled. And I've been meeting mostly companies that make Wi-Fi chipsets, access points, enterprise residential class, OEMs, ODMs, companies deploying apps on Wi-Fi, many different types of organizations. And normally when I meet them, I talk about our products, and of course I also listen to their pain points and what their customers care about. They show me their labs, what they're doing in their labs, and what kind of customer issues they're seeing. And based on that, I thought I'll share some of my learnings from meeting all these customers all over the world. In general, at a high level speaking, I feel like I've been following Wi-Fi over the last 25 years or so. And generally, technologies like this head towards commoditization phase as we get to like 20-30 year mark. So, and I think Wi-Fi is slowly getting to the point where we are starting to see some commoditization. So if you look at this particular chart here, and if you have x-axis as the time and y-axis as the product functionalities and features, initially during the creation stage, the product definition and everything is defined by engineers. So engineers define the product, and because the consumers are still not ready to use it, they don't know how to use that, and so it's primarily the power is with the producer of the product and the engineers. And as we go to over time, there is a transition phase where the burst of features are implemented, and then we go up the product functionality, and then we hit that commoditization phase where now it's about a price problem. A lot of vendors are starting to also have products, and it becomes a price game. And so that's when we hit commoditization for technology. And that's when the consumer has the power to actually dictate what they want more than the engineers and the producers. So Wi-Fi is starting to head in that direction. Ethernet has done that, and Wi-Fi over the last 30 years or so is starting to get in that direction. That is the reason why figuring out what the consumer wants is actually quite important. So as we hit that particular curve on the top, no matter how many features we implement, we talk about MLO, we talk about preamble function, we talk about latest stuff that we want to do, we've talked about multiple radios, but at the end of the day, the consumer is willing to pay only so much money for the product. So we have to figure out that you will hit basically ceiling of what you can do from a product functionality point of view when it comes to market acceptance. So that's something that we have to always keep in mind. So what consumers want from Wi-Fi at a home? So if you look at the early 1990s, people were just experimenting. This wireless thing is cool. Let me try it out. And again, in that decade, it was mostly the engineers who were actually building the products. They were the ones who were using it. But as we came into the next decade, I think people got serious. They started to say, it's ready to cut the wire, and we want to really use Wi-Fi. We want it to be really secure. And this is about the time when the operators started actually deploying Wi-Fi. So in that time, mostly the operators would actually deploy Wi-Fi, but they would use very low-end Wi-Fi routers from OEMs and ODMs at a low price point, because Wi-Fi was still not the main revenue generator for the operators. So they were still using cable TV, they were doing voice, they were doing triple play, and all these other things. Wi-Fi is still kind of a nice-to-have feature for most of the operators. So the operators were not really serious. They were not doing much of R&D. They were just getting white-labeled products and then deploying them. And the technology enthusiasts, people who actually care about that, we would go and normally when you get a Wi-Fi router from the operator in that decade, it doesn't really work that well. So you would go to Best Buy or electronics store, and then you buy your own Wi-Fi router and you set it up in your house because you want something better, right? So that's that particular decade in the 2000s. But then as you got to the next decade, now we went from just having one or two laptops doing data in the house, in the living room, sitting right next to the access point, to having a whole bunch of IoT devices spread around all in the house. Typical home in the US has 20 to 30 devices now. India is also slowly starting to get there. And we want Wi-Fi everywhere in the house, right? So at all corners of the house, we want range, we want better performance, we want quality of experience. And so the technology started to evolve, and we started having mesh routers, extenders, and so on. And then now if you look at the latest generation, so Wi-Fi is getting to a point where it's just like another utility. It's less like food, water, electricity, and Wi-Fi, right? So the idea is that when you go into a new apartment or new home, you don't go wire everything for electricity and water and things like that. It's already there. So you plug into the wall, you get you get power, right? So the idea is that Wi-Fi is slowly starting to get to the point where it has to be there. And if you look at what most of the operators and enterprise companies are doing, is they're trying to see if they can actually make Wi-Fi ubiquitous and available in the home. So if you take a typical home, the idea is some of the companies are starting to partner with building companies that are making these buildings, and they're trying to see if they can actually create Wi-Fi networks in the house where you never have to see a Wi-Fi router. So we have evolved where we have started seeing Wi-Fi routers in our house. We try to make them pretty. We try to make them very beautiful. But then we are heading to a place where you should never be able to see a Wi-Fi router. It's just there, just like you plug into the wall and you get electricity. Wi-Fi is there, and it's very much possible that as the buildings are constructed, they would run RF cables, and it's almost like a DAS system. Some of you know the DAS system in the enterprise world, where you actually run antennas all around in the house. It's possible that they would run antennas in the false ceiling, and then Wi-Fi is there everywhere. You never see a Wi-Fi router, just like you have any other utility in the house. So that's generally where Wi-Fi is heading over a point of time in the home. That's what consumers are expecting. It works all the time, every time, right? And every place. If you look at the enterprise side, what happened with Wi-Fi over the years, even on the enterprise side, we have gone through many innovation cycles. So basically, we started from a very thick AP model, and then we went into making the access point better and better. So the idea was to make the hardware very optimal. So the early innovation was in the hardware. We were trying to use better smart antennas, smart technology, and then we were trying to make the hardware better and better, longer range, better performance, better throughput. And most of the innovation went into the hardware. But as we went along, we started seeing that Wi-Fi should be deployed at large scale. So we started figuring out the scale issues. We came up with this physical controller concept, where you can have a single controller that manages all the Wi-Fi routers. And then that solved a lot of problems when it comes to security, mobility, scale, and all of that. And then eventually, as internet started becoming faster and faster, we started moving into the cloud. So now we moved from a physical controller to a cloud controller. And then now we are at a point where we're doing AI ML on Wi-Fi. So there are several of these cycles that we went through. And every cycle went through this whole idea of innovation, creating demand, creating competition, and then becoming commoditization. So it already went through many of these cycles in the Wi-Fi industry. So we went from this very place. I still remember this was probably like 20, 25 years ago, when I was intern at Cisco, I would figure out how to actually log into the access point. I'm sure a lot of you can relate to it. You would use the CLI and then basically figure out how to configure an SSID on a Wi-Fi router. So you would basically log into as an admin, and then you would get into enable mode, and then you would go configure the terminal. Then you would set the SSID. You have to go to the manual to figure out what the commands are. So every time I would go back to the manual, if I want to create an SSID on this access point, these are the set of commands I have to use. So we went from there to basically now where we can actually issue natural language commands, and we don't even need dashboards. We were talking about dashboards. We are actually past dashboards now. You can just issue natural language commands at the CLI, and you can say, okay, create an SSID with the name guest, with VLAN external, enable WPA to authentication, rotate the password daily at 2 a.m., and enable all APs on the network. So you issue a command which is a very natural language command, and then all the configurations are done automatically. And so we went from an IT person needing to know each and every command and each and every API call and each and every in the documentation to someone who can just issue a basic command and basically configure the entire network. And so innovation in Wi-Fi went from innovating on the hardware side to eventually to software and the app side, and now ease of use. So we went through all those generations of cycles for Wi-Fi. When it comes to the user again, a typical user went from running very simple apps like doing email, text, and so on a laptop with 1 or 2 devices in a home, sitting right next to the Wi-Fi router, to an entire smart home doing many, many different types of things with devices spread all across the house, right, in many, very different ways. So what does it mean for a company that is making a Wi-Fi router, right, or an access point? For many years, and I come from a test background, so for many years, we used to do a lot of testing where we would say, I'm going to run an RFC2544 test, which is a throughput test on the Wi-Fi router, and I'm going to make sure it gets the maximum amount of throughput. I'm going to push as many packets as I can through the system and test its limits, basically. That's how testing was done. And that's how we would publish numbers. In fact, if you look at competitive analysis, that's how competitive analysis run. My router got like 9 gigabits per second, your router got 8 gigabits per second. That's how comparisons were done, right? But is that relevant anymore in today's day, right? If you take one of the latest Wi-Fi 7 routers that we have tested, we have actually got consistently 9 gigabits per second throughput now in a very controlled environment. But that's not how Wi-Fi is used. We all know that. So as you go far away from the router, you just keep going a little bit far away and the throughput keeps dropping, right? And we all know this. But what happens if you actually subject the Wi-Fi router, a latest Wi-Fi 7 router, to a more realistic set of load patterns where you have, let's say, different types of traffic streams, some devices that are near, some devices are medium distance, some of them are far, some of them are doing video applications, voice applications, some stations are 11N, some of them are 11AC, they are using different MIMO types, channel bandwidths, they are on 2.4, 5 gigahertz band. So that is what a Wi-Fi router actually faces today. It is not million packets hitting the Wi-Fi router's receiver all at the same time, same packet size. That's not how Wi-Fi routers operate. So if you subject the Wi-Fi router to such a realistic load when the transmitter and receiver of the router are active at the same time, and all the bands are active, and they're all managing different packet sizes, packet rates, different MCS rates all at the same time, then what happens to the router, right? And the same Wi-Fi router that gave us 9 gigabits per second crashed multiple times just with a small amount of load. We're talking about 100 Mbps, right, across all these scenarios. And it's basically, if you run it over a time, and I don't have the full chart here, but every certain intervals, this router keeps crashing all the time. It's which consistently works at 9 gigabits of throughput under ideal conditions, right? So these are the kind of realistic scenarios, real problems that the consumers really care about. Now, if you take the same Wi-Fi router and you subject it to different types of traffic streams, like in this case, we were trying to do just simple 18 traffic streams, uplink, downlink. Some devices are near, some devices are far. They're all doing different protocols, different packet sizes, packet rates. And we did only a total of about 70 Mbps. We're not talking about 5 gig, 10 gig, 9 gig, just 70 Mbps traffic, right? And with no QoS tagging on all those traffic streams, we saw the throughput on this router varying so much when we're constantly running this test over time, right? And if you look at the number of retries, lots and lots of retries on this router, and then even the 5 data rates. If you look at the 5 data rates, they're fluctuating a lot when we have no QoS tagging. Now, all this traffic is running in best effort mode, right? And now if you run the same exact traffic with QoS tagging enabled, with various traffic streams doing best effort, background, voice, video, QoS, and so on, the exact same router, exact same conditions, just by enabling QoS tagging, we see consistent throughput, and then we see a lot less retries, only 100 packets per second here, and then the 5 data rates are also much better, right? So we could have the latest Wi-Fi router, we could be using MLO, we could be using 4K QAM, the highest data rates, 320 megahertz channel bandwidth, but at the end of the day, this is the reality, right? And this is what we need to really care about more than anything else, because that's what the customer user cares about. In any given environment, we are subjected to this kind of load, different types of devices. That's the most realistic environment that we can see. As an example, we have one of our labs where we have what we call as a smart home lab, which has 200 plus devices. And these are all the devices that you would see, different types of Wi-Fi devices, smartphones, tablets, laptops, Fire sticks, light bulbs, cameras, thermostats, all types of devices in this particular lab. And the idea was to see how well the Wi-Fi router operates in very realistic conditions when we have real devices. So it's a very interesting story. When we were setting up this lab, I wanted to go buy all these devices, and I was thinking that maybe 50% of the devices I have to buy from overseas and somehow have some friend bring them for me when they're coming from the US. But when we went and looked on Amazon.in, I was able to buy almost all those devices in India, right? And 100% of these devices are actually available in India, which is great, which means that we are actually starting to have many of these devices, and I'm talking about coffee makers, air fryers, washing machines, and ceiling fans. They all have Wi-Fi radios in them, right? The interesting part is, of these 200 devices we have in this lab, about 70% of the devices are 2.4 gigahertz only, right? So we're talking about 5 gigahertz, 6 gigahertz, but this is the reality. I mean, a lot of these devices are still 2.4 gigahertz. And there is a reason why. They really don't need that much bandwidth. They need better range. If you're talking about installing a doorbell outside in the door, then that needs better range. So you get better range in 2.4 gigahertz. You only transmit a little bit of data. And so you want to transmit at the lowest possible data rate to get the most reliable transmission. So they don't really care about being a good neighbor in the Wi-Fi world. They just want to implement the cheapest solution possible in the most practical way. So they just use 2.4. And many of these devices are even using 11N. Some of them may be G as well, right? So now how does this affect the latest Wi-Fi 7 router if this is the scenario that you have to deal with? We did some analysis on various types of IoT devices we have in our labs, like cameras, home pods, and things like that. And a lot of these devices operate in the 2.4 gigahertz band. So if you look at what kind of throughput is needed, so if you take a video camera, it only does about 1 or 2 Mbps traffic. So that's about 1 or 2% of the theoretical throughput that's available in the 2.4 gigahertz band. So to consume 1-2% of the theoretical throughput, it actually takes up about 25 to 30% of the medium time, right? If you measure the medium utilization of these devices. Why? Because, of course, they're transmitting the lowest possible phi rate, and they're not aggregating any frames. And there's also a lot of chattiness in the way these devices operate, and so they take up a lot of airtime. So all it takes about 5 or 10 of these devices, which is very common to have. You'll have light bulbs, you'll have smart plugs, you'll have all these devices in the home, and that takes out about 60-70% of your available bandwidth on the 2.4 gigahertz band. So now, if you have, let's say, a phone that is doing a WhatsApp call in the 2.4 gigahertz band, how is it going to manage that is an important problem. You could have the latest Wi-Fi 7 router, but you still have a problem because even some of the phones that you're using are still on 2.4 gigahertz band. So if you run a simple WhatsApp video call in this particular setup, all we did was we took a phone and we played a real WhatsApp video call with just under ideal conditions without any congestion. And then we added just about 4 or 5 different types of devices that are low-end devices. And you can also already see that the WhatsApp video call is clearly affected by and we are running this test on the latest Wi-Fi 7 routers. So these are the practical problems that we should be discussing when it comes to deploying Wi-Fi networks. So how do we do this testing? So what we have done here is the idea is to, as a test equipment manufacturing company, we also changed our method. So originally we would always focus on throughput, and we would run the test under ideal conditions. We would run RFC 2544. We'll say, let us try to test each aspect of Wi-Fi performance separately. So we'll run a throughput test, we'll run a range test, we'll run roaming test. Every aspect is tested separately, right? But now we started looking at, okay, that's all fine, but we need to test it as an entire system. And so that's the reason why we're doing things like setting up these kind of environments where we can create this idea of a home in a box, where you're trying to mimic an entire home environment in the lab, and you try to bring all these combinations of different types of home environments in a lab. And now if you can test a Wi-Fi router in these realistic conditions where you're subjecting it to different types of client load, traffic load, different applications all at the same time, and now you're measuring user experience. So what is the user experience like when you're running, when you have so many different types of traffic streams, all operating on different types of clients at different distances from the Wi-Fi router, and then what is your user experience like? And this is basically what we're trying to do in these kinds of setups. So here you can see that we are trying to set up different traffic streams, different distances, and we are making different types of measurements. So the kind of measurements that I showed you of how basically different types of apps work in this kind of realistic conditions. So other Wi-Fi 7 user experience concerns that at least we came across when I was speaking to customers, when I spoke with many of the companies that I work with, the number one concern that I have is not MLO working, is all these features working. That's not their concern. Their primary concern is, I just deployed a Wi-Fi 7 router. There is one legacy Wi-Fi device in my home, and it was working fine when I had my Wi-Fi 6 router. Now it doesn't connect. So connectivity, basic connectivity, is the biggest problem that the customers of our customers are facing. Something as simple as Wi-Fi 7 has a lot of new information elements and lots of new things, and sometimes the legacy devices might not like that. Like we talked about WPA3 information elements and things like that. And so how do you deal with that issues, right? So we talked about MLO, how MLO across multiple links can increase performance, increase throughput, increase reliability. But what about roaming? How does MLO actually affect roaming, right? There was a really nice presentation at the WLPC, I think, called Roaming Wars, which was talking about how roaming is affected by various of these new features. So there's a nice presentation on how roaming is affected by MLO. So normally when you are actually roaming a client between access points, if you have in the case of MLO, when you have MLO turned on, the number of roams actually decreases because the station, rather than moving to a different access point, can actually move to the 2.4 gigahertz band on the same access point, right? And use a different link if it's using EMLSR or and things like that. So that generally makes roaming more efficient. But is that what you want? So if the client stays with the same AP, and if you're not doing load balancing properly, what about the system level performance of the access point? So now we are looking at a Wi-Fi level. We are saying, okay, at a Wi-Fi level, it is better that the client is staying with the current AP. But if all the clients are staying with the current AP, we have CPU limitations on the access point. We need to think about that. We have to remember that, as I mentioned, Wi-Fi is getting commoditized. So you cannot sell a Wi-Fi router for like $5,000, right? The cost is going down. It has to become compact. No matter how many radios, how many interfaces you put on it, it's still cost sensitive, right? So we need to figure out that even though at a RF level performance is better, at a CPU level it is CPU bound, and you need to make sure maybe it's better that the client roams to a different access point because there are multiple access points available, and you load balance the devices across multiple physical radios and physical interfaces, right? How does MLO affect band steering? How features like preamble puncturing work when you actually do DFS? So normally when you do DFS, you switch channel, but when you're doing preamble puncturing, you have a way to actually puncture that band and stay on. So is that features working well when you have legacy clients? If you have features like MBSSID, for example, where you're putting multiple BSSIDs in the same beacon, how does it affect your channel scanning? How does your, there was one interesting paper that I saw on how these channel planning algorithms work. They actually look at the RSSI from the beacons. And so when you're seeing a beacon, you're seeing the RSSI from a particular beacon, but within the beacon, there are many networks there. And they're all at, some of them are 2.4 gigahertz network, some of them are 5, some of them are 6 gigahertz network. They're all at different transmit powers. So you're not able to detect all of that when you're doing channel scanning because you're only seeing the beacon that is the main beacon that's being transmitted. So how does that affect your channel planning in the legacy channel scanning and things like that? So these are all the things that we need to care about as we work on all these features. So yeah, I'm going to close with this. For those of you, anyone who is new to Wi-Fi, so we have some of this material available. If you search for Wi-Fi fundamentals, this is some of the things that I covered from basics in the case of Wi-Fi, and then this is about me. So thank you all for your time.
Yeah, thanks, Sitarama. So while I get Kishore's presentation, there are time for a few questions. Please raise your hand. Mike will come to you.
Yeah, I have a question regarding your WhatsApp video call which you are showing. So, at least in my test, when I run it multiple times, I didn't find the other devices were not actually saturating the traffic. Because mostly the devices which you show were like IoT kind of device, right?
Right.
Which runs at max 1 Mbps maybe. So when the link was not saturated, actually the video call or voice call was not deteriorating so much in the Wi-Fi 7 because the channel utilization and other things were also less. So can you throw some light like why it was suffering, the WhatsApp call on the Wi-Fi 7 network?
Yeah, so it's possible that we ran it in a different test environment. We actually ran it in real environment, in a real house, under real conditions. So
yeah, for whatever I ran also was in real environment. So
okay.
with Samsung device and multiple access point vendors.
Right.
So I didn't actually find a need for video call to suffer in the Wi-Fi 7 environment when the link is not saturated. So did you try to saturate link somehow, or I was just interested in that slide?
No, we didn't necessarily try to saturate the link, and of course there is some more detail involved, so maybe we can just discuss this offline and discuss in more detail. Yes.
Please pass the mic to one more. Vijaya, you can ask one more question.
So your offering of that home in the box test solution, is that solution already ready for customers or?
Yes, ma'am.
purchase?
Sure. Yeah, we can discuss that. I'll come and meet you and maybe
Okay.
we can
Yeah,
discuss
sure.
that. I didn't want to
Yeah, thank
spend that time on this topic.
Last question. Please raise your hand so that they can come. Otherwise, they may not reach you.
Like from the user perspective, like is it better to switch to Wi-Fi 7 or we can stay in 6? Because according to your point, like legacy clients won't connect or some issues with the customer perspective. Is it good to switch for Wi-Fi 7 or we can?
I feel like Wi-Fi 6 is good enough. I mean, you can, as long as you're implementing better algorithms to actually take care of these real world problems, you can solve the problems with Wi-Fi 6 or with Wi-Fi 7. It doesn't matter. What needs to be solved is these kinds of, you need to implement better algorithms, QoS algorithms and other things that are relating to the user experience problems that you're facing. So if you do that, it doesn't matter Wi-Fi 6 or Wi-Fi 7. So,
Thank you. Thanks, Sitarama. Thanks.